classes or events to attend to. So, kaya lang kasi sayang yung araw. Okay. Okay now, guys. Do you see now the board again? Guys?
Opo.
Okay.
Opo, sir.
Yes, sir.
We're going to discuss today logarithmic integration and in particular improper rational function, the integrand, no? If your integrand is a rational, improper rational functions, then you can apply logarithmic integration, but not course, but not all the time. So there will also be time where you cannot apply this, no? As long as you will come up with after long division, you will come up with um, integrals that can be evaluated by the previous methods. Okay, guys? Okay. So let's have so again, this is the rule, or I think I had this as a remark before, no? Rule. If the integrand is a rational function, that is improper, no? We're talking of improper in particular. Let me revise that. Is an improper rational function, rational function so that is the degree of the numerator is greater than or equal to the degree of the denominator you have to perform long division first, no? Perform long division first. Long division first. Before evaluating the integral. Okay, guys? So, let us have exercises. I give you, I think, 2 already. Exercises. Number 1. So, we are asked to evaluate the given integral. Okay, number 1. So let's say we're given the integral of 2 x squared minus 20 minus 13 x plus 23 quantity dx all over x minus 4. Okay? If you're going to look at the denominator, it is first degree. Numerator, second degree. And the integrand is a rational function, improper. Okay? Now, since this is improper, so what's the rule? You're going to perform long division first. So let's divide. You can apply synthetic division. No? By synthetic division, you can have also long division if you want. By synthetic division, we have 2, negative 13, positive 23. Our multiplier here is 4, no? So that is opposite to the constant here in the linear denominator. So after that, so bring down this first number here, multiply by 4, so that is 8, add negative 5, multiply by 4, negative 20, so getting positive 3 as the sum for this column. No? So this is the remainder, and this is the coefficient of the linear term, and this is the constant term. Okay? So hence, the integral can be written as what? Integral of 2x minus 5, then plus 3 over x minus 4 quantity dx. So we can apply here term by term integration. No? So for the first term, I can write that as 2 integral of x dx minus 5 times integral of dx. And then finally, plus 3 integral of dx over x minus 4. So the first one is simple power. So that is 2 times integral of x dx is x squared over 2 minus general property integral of du. So we apply that integral of dx in this case. So 5 times x. Okay? Then plus 3 times. Now, if you're going to look at the numerator, so this is du of what? This is du of this denominator. Okay? So if you take the denominator as our u, the numerator is its du. You can do that by inspection. So hence we have du over u. So what's the integral? Ln of the absolute value of x minus 4 plus c. Simplifying the first term, we have x squared, then copying the rest of the terms. Okay? So negative 5x plus 3 times what? Ln of x minus 4. Then, plus what? Plus c. Okay, guys? Guys, let's have number 2. If you don't have questions, you can raise your hands, if you want. If you have questions. So, let's have this one. So, 6x cubed. Let's have integral of 6 x cubed, then plus 5x squared minus 14x, and then minus 7 quantity dx. Okay? All over 2x plus 3. So again, the integrand 6x cubed plus 5x squared minus 14x minus 7 all over 2x plus 3 is an improper rational function. So as a rule, we are going to divide first, no? So we can apply here synthetic division again. So that's the easiest way to perform division. So by synthetic division, copying the coefficients 6, 5, negative 14. Be sure the all powers are present. Now, in case there is a missing power, you're going to replace that by 0. No? So for the constant coefficient. So we have negative 14, then the last one, negative 7. Our multiplier here is opposite to the constant term. So that is negative 3. Is that right, guys? Then I will have this. But I have an additional row. So I have to divide that by what? Divide by 2, the coefficient of the linear term. Okay, guys? So bring down, divide by 2, so that is 3. Multiply by negative 3, that is negative 9. Add, so that is negative 4. Divide by 2, negative 2. Multiply by negative 3, positive 6, add negative 8, and then divide by 2. So that is negative 4. And then multiply by negative 3. That is negative, so positive 12 na. Add, so that is positive 5. So this is the remainder. Can you follow, children? Hi, guys. Big children. So these are the coefficients of the quotient. No? So the quotient, the degree is 2. No? So this is coefficient of quadratic, then linear, and then for constant term. Okay? 3, negative 2, negative 4. Remember that. So we have the integral now becomes integral of 3, no? 3 x squared, then minus 2x, then minus 4, then plus the remainder 5 over 2x plus 3, no? Is that plus 3? Okay, guys? Hi, guys. Guys.
Opo.
Okay. Ito si Dominic ba? Ito hindi na Dominic. Edward. Baka lagi naka-idle yata itong batan. Ay, Dominic. Hindi ko alam kung...
Yes, sir.
Yan. Gumalaw na. Hindi ka idle, ha? O sige, what is the first term? What's the integral, Dominic? Dominic Edward. Dominic. Kala ko buhay na. Nawala. Dominic.
Ano po yun, sir?
What is the
Medyo choppy po yun, ano.
integral of the first term? Integral of the first term. Nawala na. Umalis to si Dominic. So that is x cubed minus x cubed over 3. Cancel with the 3. What about negative 2x? Oh. Serrano.
X squared po.
X squared over 2. Cancel.
Hindi po,
no?
X squared lang po.
Oh, x squared only, no? Minus 4x na? What about the last term? 5.
5.
Let's fix that now because this is integral of, let's write, integral of dx. I put the 5 out and then I need in the numerator the differential of the denominator. If my u is 2x plus 3, what is my du, guys?
X squared po.
2 dx. What is the derivative of 2x? 2. Then dx. Okay? What I need to supply in the numerator? I need to supply 2. And then outside, balanced by 1. Okay? So this now becomes 2 dx over 2x plus 3. So this makes now du over u. Okay, guys? So copy x cubed minus x squared and then plus negative 4x and then plus 5 halves. What is du over u? What is the integral? Emmanuel Renaldo?
Sir, ln 2x plus 3.
ln of absolute value of 2x
2x plus c pa po.
so plus 2. Okay, guys? See, it's very easy. Let's have this last involving rational, improper rational function algebraic in form. So let's say I have integral of x to the 4, then plus x cubed plus x squared minus plus 4x minus 6 all over x squared plus 3 quantity dx. So again, this is improper rational function. No? So let's perform long division first. Now, but this time, we apply what long division? Yung talagang long division. No? So let's start. So outside is x squared. And then plus 3. Inside is what? Our divisor. So our divisor is dividend, x to the 4 plus x cubed plus x squared plus 4x minus 6. So, but let us fix the divisor. So the divisor, you have to complete the number of terms. So what is the missing power? Linear, no? So x. So we have to put 0x. So we have x squared plus 0x and then plus 3. Okay? So x to the 4th divided by x squared, that is x squared. X squared divided times x squared, so that is x to the 4th. And then plus 0x cubed, and then plus 3x squared. Get the difference? So what's the difference? 0. This is x cubed. This is negative 2x squared. Bring down the linear term. So that is 4x. So then divide x cubed by x squared. That is plus x. X times x squared. X cubed. Then plus 0x squared. And then finally, we have plus 3x. Okay? So again, get the difference. What's the difference? 0, negative 2x squared, and then here, plus x, bring down negative 6. Am I correct, guys? So negative 2x squared divided by x squared, that is negative 2. 2 times x squared, that is negative 2x squared. And the negative 2 times 0x, that is 2 times 0x. No? So 0x, negative 2 times 3, negative 6. So, okay, guys? Yan. So we now have 0. This is x. 1 minus 0 is 1. So this is 0. So the remainder is x. So this is the remainder. Okay? So let's now rewrite the integral. The integral can now be written integral of, what's the quotient? X squared, and then plus x cubed, x minus 2, then plus the remainder, x over x squared plus 3. So we can now perform term-by-term integration. Integral of x squared dx plus integral of x dx minus 2 integral of dx, and then the last integral, we have integral of x dx over x dx over what? Over x squared plus 3. Okay? Now, in the last integral, to be able to evaluate this, so we have tried to apply integral of du over u, logarithmic integration. Let's see. Let's take u as x squared plus 3, checking the differential if it is in the numerator. So that is 2x dx. But looking at the numerator, it's not exactly the differential of the denominator. So what do we need to supply to complete the du? So we multiply by 2 and then balance outside by 1/2. Okay, Dominic, welcome back. Bakit nawala ka, Dominic? Ay, Dominic. So we now get...
Nag-reconnect po, sir.
Oh, sige. Oh, what's the integral, Dominic, of the first term? Integral of x squared dx. X what? Oh, anong integral ng x to the n dx? X to the n plus 1 all over n plus 1. Oh, anong integral ng x cubed, Dominic? Dominic. Ay, Dominic. Ayan, sumagot. Don D. Emmanuel, yung mga nagre-recite lagi, natatanda ko yung mga pangalan. Don D. Don D.
Hello, sir.
Oh, what's the integral of the first term? Don D. Ayun. Francis. Tale. Francis. John Dale.
Sir, x cubed over 3.
Who's answering? Who's answering, guys? What's your name, guys? Okay, so x cubed over 3. What about the second term?
X square over 2.
X squared over. When you read it, not x squared, huh? Not x squared. It's x squared. X squared. X cubed. X to the fourth. Not square, ha? Not x squared. X squared with D. X is squared yan, pag tinuloy mo. Then, minus what? Minus, next, iho. Nepomuceno. 2,
2x po.
2x. And then, what about the last one? 1/2 integral of du over u. What is this? du. What is the denominator? U. Integral of du over u. ln of
ln of absolute value of x
Okay.
squared plus 3.
plus 3. And no need for absolute value, no? Because x squared plus 3 is never negative. Okay? Yan.
Okay po, sir.
Okay. Number 4. Be ready with others, ha? Ayan. Pag yung names nyo natawag and hindi nasagot, ay walang plus. So, number 4. So, we have integral of, let's have tangent, ay, ln, let's have ln. 9 ln o squared r minus 3 ln r, 3 ln r, then minus 8 quantity dx, dr all over r times 3 ln r, 3 ln r minus 2. What about this, guys? This is not a rational function, the integrand. But if you're going to look at ln r, that takes the form of rational function. But it is rational function in what? In ln r, okay? And it is improper because if you're going to consider the degree of ln r relative to ln r, if you take at, let's say, like an x, so ln r is our x, so the exponent is 2, so of degree 2. So since r in the denominator here, you see r, there is no ln, so it means it is not part of the rational function. So it is part supposed to be of dr, no? Meaning part of the differential later. Okay, for you to see clearly that it is a rational function, improper, let us use simple substitution. Okay, so let's say x be equal to ln r. Okay, guys? So then, what can we say about the differential of x? What is the differential of x, guys? Sarmiento, Angelo. What's the differential?
1 over r.
1 over r times dr. Okay? Yan, 1 over r times dr. Because we want differential. So, the integral now, we can write it as integral of 9. What is ln r? That is x. So, then square it because ln r squared. Then minus 3 x, that is our ln r, minus 8 all over 3 ln r, so that is 3x minus 2. And what is dr over r? Dr over r, guys. So that is dx. Is that clear? Carl Andrew?
Yes po, sir. Yes po.
Okay. So let's have remember the given, this resulting integral. I can't remember that anymore. So we have, what's the integral again in terms of x? Ano yung pinaka-rational function in x? So that is 9. Ano nga yun, guys? 9x squared minus 3x minus 8 na? All over 3x minus 2. Okay, guys? Let's now divide. So by synthetic division, so we now have 9, negative 3, negative 8. Our multiplier here is opposite of negative 2. So that is 2. And then we have this line. And then another line for, because of this, no? Or such. So divided by negative 3. I mean, divided by 3, sorry. So 9, bring down, divide by 3, so that is 3 times 2, 6, add, that is 3, bring the add, 3 divided by 3, that is 1, times 2, that is 2, then get the difference, sum, that is negative 6, okay? So this is the remainder. So that is remainder. Did you understand this synthetic division, children? Ganyan ba kayo mag-divide? Pag merong coefficient yung x. Hi, guys. Or is it your first time to see such synthetic division?
Pag ganyan na po.
Oh, yeah. So we now have integral of, what's the result? So 3. What's the degree? X, no? 1, I mean. So 3x plus 1, then plus negative 6 over 3x minus 2. And quantity dx. So applying integration term by term. So we have integral of x dx, then times 3 outside. You can put it out because it is a constant, plus integral of dx. And then lastly, we have 6 integral of dx over 3x minus 2. Now, for the last integral, so that leads to du over u, no? Integral of du over u. So our u is 3x minus 2. So du is equal to 3 dx. So we miss what in the numerator? We need 3, no? So I'm going to get it from 6. So what will be left after getting the factors 3 from 6? So there will be 2 left, no? So for the first integral, we have 3 times x squared over 2, and then plus integral of dx, general property, so that is x, minus 6 times ln of. So this is now, I am going to split, no, the 6 into 2 times. And then I'm going to give the 3 inside. Is that clear, children? Because I need 3. Or you put 3 balanced by 1/3. 6 over 3, that is 2. 3x minus 2. So the last integral is what? What is the last integral, guys? 2 ln of absolute value of 3x minus 2. Am I correct, children? Huh?
Yes po.
Okay. So we now have, to put it back to its original function, huh? But x is what? But x is ln r. So we have 3 halves, ln r, so that is x, quantity squared, plus ln r minus 2, ln of absolute value of 3, ln r minus 2. Okay, guys? Do you have any question with that, guys? Guys?
Wala
Elvin
po,
work?
sir.
Ano po?
Wala po,
Okay.
sir.
Number, what number now? 5? Finish pala.
5 na po.
Number 5. Let's see if you can have this. I want to try this one. So we have tangent, tangent cubed x minus tangent squared x, then minus 13 tangent x minus 12, okay, multiplied by secant squared x dx all over, so all over, ay, tangent x plus 2. Tangent x plus 2. 2 here is not part of the tangent, huh? So it is like 2 plus tangent x. Okay, guys? Now again, this is not rational function in x, but if you look at the tangent, it is rational function in what? It is rational function in what? Don D. Manuel. David Ludi. Andre. It is rational function in, and in fact, it is improper, no? Improper rational function. In what function? Rational function in tangent. In tangent x, okay? So let's simplify that. Let y, let me use y, be equal, because this is already in terms of x, be equal to tangent x. Hence, dy is given by Emmanuel Jordan. What is the differential of y? Emmanuel.
Second square po. Second
Secant
square dx po.
squared x dx. Very good. Which is actually in the numerator already, no? So this is dy, that secant squared x dx. So the integral now becomes, in terms of y, we have y cubed minus y squared minus 13y, and then minus 12 quantity dy, so that is secant squared x dx, all over tangent x, so that is y, then plus 2. Okay? Let's apply synthetic division. By synthetic division, we have 1, negative 1, 13, negative 13, negative 12, and our multiplier here, opposite to the constant 2, opposite in sign, so negative 2. Then, bring down 1, multiply by negative 2, add, multiply by negative 2, so this is 6. Then, add negative 7, multiply by negative 2, positive 14, add positive 2. So 2 is remain there. The degree of the quotient is 1 degree less than 3, no? So that is 2 because denominator is linear. So y cubed, so when divided by a cubic, when divided by a linear, that is quadratic. So this is quadratic. So the integral now becomes integral of quadratic, no? I mean, y squared minus 3y minus 7, then plus 2 over tan y plus 2. Y plus 2. Quantity dy. Okay, guys? Guys,
Apa, sir.
check nyo ha, tama ba yung aking division? So, let's now have, yan. Hala, hindi na natin kita. Let me copy that, no? Let me move, copy. Yan. I will copy this on the next slide. Yan. Okay. So, we can evaluate this using term-by-term integration, huh? So, integral of the first term, but of course, you can do it mentally if you want. Minus 3, integral of y dy, and then minus 7, integral of dy, plus 2, integral of dy over y plus 2. So first term, we have y cubed over 3. Second term, 3 y squared over 2. Then minus 7 y, then plus 2. So this is already du, and this is u. D over u, what's the integral? Ln of the absolute value of, yan. So let's put it back to its original function. So ang y is what originally what function? Tangent. So 1/3. What is y? Tangent. But it is q raised to 3. So tangent cubed. Then x minus 3 halves. Tangent raised to 2, no? So tangent is squared x minus 7 times tangent y. Tangent x, then plus ln of 2 times ln of absolute value of tangent x plus 2, then plus the beautiful c. Any question, children? Children of the Philippines? Jerry,
Wala po.
Robert? Since no more questions, let's now move to integration leading to exponential functions. Okay? Then after this, I'm going to give you quiz about this. No? Expect this coming week, you're going to have quiz, but of course, you will be having also graded exercises about logarithmic integration and exponential integration. Okay? And then you will have your first exciting quiz. So let's now move to exponential functions. Yan. Integration leading to exponential functions. So I'm going to remove this. It's not anymore improper integrals. So this is the one that we had. So we now have exponential integrations. Yan. Okay, guys? Can I make it larger? I'm going to make it larger. Nadideform. Yan. Exponential integration. Okay. So far, the formulas that we had, again, children, general power formula, that is integral of u to the n du is equal to u to the n plus 1 all over n plus 1. But what is the restriction? David Ludi? What's the restriction for general power, Ludi? Trixie, Marie, Rod, Dominic, and it should not be what? Jordan, Philip. Hi, guys. Guys, n should not be equal to negative 1. Okay? If n equals 1 in the general power formula, which is u to the n du, then you can apply logarithmic integration. Because what you will have u to the n, u to the negative 1. Integral of u to the negative 1 du, you have to express it as integral of d over u, and that leads you to logarithmic function. Ln of the absolute value of u, then plus c. And then the third one, which we are going to have now, is integration leading to exponential functions or exponential integration formulas, because we are going to have two, or exponential integration. Let's now begin. And exponential integration. Exponential integration formulas. So let u be equal to f of x. Assume this is a differentiable function. Is it recorded, guys? Na-record ko ba? Guys?
Yes po, sir.
Okay.
Yes po.
Then, number one, the integral of a to the u du is equal to a to the u over ln a plus c. Where here, where a is positive but not equal to negative, not equal to 1. Okay? So again, what is a here, which is a constant that is positive but not equal to 1. And then a special case, if a happens to be e, so you will have integral of e to the u. If a happens to be e, so this formula now becomes integral of e to the u du, and that is equal to e to the u. So e to the u, but what is ln e? Because a is e, but ln e is 1, so we don't write that anymore. Okay? Then plus c. So here e is approximately, it is a constant, approximately equal to 2.71828. So we have two formulas for exponential functions, no? Integration leading to exponential functions. Now, take note here that in the integral, yan. So again, in the integral, yan, integral of, let's say, a to the u, yan, du. Let's take the general form of it, because e to the u is just its special case. Now, in this integral, we call a, this is a constant. This is a constant, no? It is the base, which is a constant. It is base, which is what? Which is a constant. Okay? Of course, different from what? So it is a constant greater than 0, but of course, not equal to 1. And then u here is the power function, I mean, the exponent, no? So this is the exponent. So that is the exponent, yan, of the base. Yan. And it is a function, which is a function, yan, other than a constant, no? So meaning u is really a function, no? Yan. And then a to the u is it is a power, yan, yan, different from what? Different from a which is actually not a constant, yung a to the u. It is a power function. It is a power function different from a constant. And finally, du here is the differential of the exponent, no? Meaning of this u. Differential of u. Yeah. Of the exponent u. Okay? If all of these things are satisfied, these requirements, then this integral is equal to, again, a to the u over ln a plus c. But remember, a is greater than 0, but not equal to 1. Is that clear, guys? And so let's apply that in evaluating integrals. Okay, this formula. Let us have the following exercises. Evaluate. Yan. The given integral. The given integral. Number 1. So integral of 2 to the x to the 4th, then x cubed dx. Now, if you're going to look at the integrand to x to the 4th x cubed, there are two powers, no? One is 2x to the 4th, and then the other one is x cubed. But if you are going to look at x to the 4th, x cubed is possible to be its derivative, no? So it means what we are going to consider as power is the 2 to the x to the 4th. And since this is constant, the base, and the exponent is a function, then this is exponential integration. Huh? So let's check. So what is our u here, guys? X to the 4th. What is our a? Our a is positive what? Guys, positive 2, no? And then, what is du? Guys, what is du? For x cubed dx. Looking at the integral, now, in the integrand, together with the dx, so notice that our du is not yet complete. So, this x cubed is what? Has a missing factor to be du, na? What is that missing factor? 4. So we have to supply that so that this will take the form of a to the u du. Okay? So let's apply, what do you want? Simple substitution or correction factor? If you're going to have correction factor, then this can be written integral of 2 to the x to the 4th times we have x cubed dx. So we're going to supply 4 here as a factor, then balance outside by 1/4. So finally, we now have what? So this is now read as 1/4 integral of a to the u du. So what is this, guys? This is u, not u. What about this? This
DU
is
po.
du, no? Not dmi. Okay? So what's the answer? 1/4 integral daw ng a to the u du is a to the u over ln a, but what is our a? 2, and then plus c. Or if you want, you can express it as one term only in the denominator, meaning 4, I'm going to incorporate 2 to 2, no? So this can be written to the x to the 4 over these two factors for ln 2 can just be ln 16, meaning ln 2 to the 4th. Remember, 4 can be exponent of 2, right? You can have that if you want. Or of course, you can have 2 to the x to the 4 over 4 ln 2. Okay, guys? Guys?
Yes po.
Okay, next, number 2. Oh, by the way, if you want, you can have simple U substitution. Let's say you want by simple U substitution. Simple U substitution. If you want simple U substitution, but it's nice about simple U substitutions that you can clearly see the formula, no? Because you will have really a to the u du form or e to the u du form, okay? So, given the integral of 2 to the x to the 4th, then x cubed dx. So again, our u here is what? X to the 4th, getting its du, that is 4 x cubed dx, with our a equals 2. Now, we need to express this given in terms of what? U. So here we have to solve for du over 4. If we solve for du over 4, that gives us x cubed dx. So this part, I can express that in terms of du over 4. What about x to the 4th? So I can write that as u, no? So no more letter in terms of x. So everything now is in terms of u. So 2, then this is u. What is x cubed dx? That is du over 4. Okay, guys? So 1/4, I can put it out because I don't need that. So this is now in 1/4 integral of 2 to the u du. So what is the sound, children? If the sound is integral of a to the u du, a to the u du, what's the answer? The answer is a to the u, yan, a to the u over ln a, then plus c. Okay? But of course, u is not the original. So that is 1/4. Then ln o, I mean 2 times what? 2 times 2 to the u, but u is x to the 4th over ln 2, no? Plus c. And then, that is equal to 2 to the x to the 4th over 4 ln 2 or ln 16. Did you understand why it is ln 16, guys?
Yes po.
ln 2 to the 4th, no? That is ln 16. But of course, 4 ln 2 is also accepted. You do not have to worry about that. Okay, let us have number 2. Integral of, let's say, e to the 5 tangent of x squared, then x secant squared x squared dx. Oh, what about this, guys? So let's try if the exponent of e is our possible u, no? So let's see. Let's take u equals 5 tangent x squared. Our A is E. So that is direct. We have a direct formula for that. Integral of e to the u du is equal to e to the u plus c. Again, what is E? Approximately 2.71828. That is an irrational number, Napierian-based. So, A here, what is du, guys? What is du? Francis. Ethan Gerard. Jordan Philip. John Dale Rick. Ang ganda pa naman ng pangalan. Marcus. Tunog mayayaman ng mga pangalan. Wala na si Dominic. Na-out ng tuluyan. Guys, Marcus Andre, Emmanuel, Merck. What is the DU, guys? Hoy, guys.
10x seconds.
5, then times what? Times derivative of x squared is 2x, no?
Opo.
Then tangent, that is secant squared of x squared. Okay? Then don't forget the dx because this is differential. Simplifying, that is 10x secant squared x squared dx. Okay, guys? Let's apply simple U substitution. By simple U substitution, and simple U substitution, so meaning we're going to express everything in terms of U, no? So we now have, from here, what is x secant squared x squared dx? That is du over 10, right? No?
Yes.
So that is x secant squared, x squared dx. So the given now, I can express this in E. So 5 tangent x squared, that is u. Then x secant squared x squared dx, that is du over 10. Okay? So we don't need this 10 in the denominator. Put it out. So 1 over 10 integral of e to the u du. So this is exactly the formula now. What is the integral of e to the u du, children? That is e to the u, no? Still e to the u. Okay? Then plus c. But what is u, guys?
5 times x squared.
Okay, so it is 5 tangent of x squared. Okay, very good. Yan. That's it. See, so you have already 3 formulas, aside from the general properties of indefinite integrals. Number 3, so integral of 5 pi to the sine squared 2x over numerator, dagdagan pa natin. Let's have sine 4x and then dx in the denominator. Let's say 5 raised to sine squared 2x. Or let's see if this is solvable because I just made it. Let's see if there's a solution for this. Okay, guys, let's check. Which do you think is the possible u? Or do we need to manipulate so that you can come up with a to the u form? Is it already in a to the u form, guys? Aljedi, Charles Dominic, Francis. Guys? Guys, Marcus, Andre. Boy, guys. Is it already in the A to the U form or do we still need to write? We still need to write now. Notice that pi and 5 have the same what? Exponent, no? So I can write that as what? Integral of pi over 5 raised to what? The common exponent. Sine squared of 2x. All we need to verify if the remaining sine 4x is the differential of this exponent of pi over 5. So it means our u here, let's try sine squared of 2x. Our a is equal to pi over 5. Okay? So remember, our a is constant as long as not equal to 1 and then greater than 0, no? So what is du? Emmanuel Jordan. Emmanuel Rinaldo. O
2
guys,
sine 4x po.
2,
Sine
2
4x.
times, drop muna, 2 times sine, then times
4.
2x, times cosine of 2x, then times derivative of 2x, 2, then dx. Why is it so? This is power, no? Drop the exponent, copy the base, that is sine 2x, get the derivative of sine 2x, cosine 2x. But the derivative of 2x is what? 2. Then dx because you want it to be du. Okay, guys? But what is this, children of the Philippines? From your trigo. Oh, what is this, children of the Philippines? Guys, that is what? Huh, guys? That is equal to, guys, equal to sine of 2 times 2x. So, and that is 4x. Remember, my angle theta here is 2x. This is 2 sine theta, cosine theta is sine 2 theta. But what is my theta? 2x. Okay? But there is still 2. So, 2 times, then dx. Okay, guys? So, which is now almost this differential. So, the integrand together with the dx, almost this what? This du, no? So, let's have correction factor. So, again, I'm going to apply correction factor. By correction factor, so meaning I'm going to correct the differential by multiplying it by 2. By correction factor, children, we have integral of pi over 5. You can use substitution if you want. Huh? Sine squared of 2x times, I'm going to multiply by what? By 4, by 2, I mean. And then balance outside by 1/2. So to compensate, no? Remember ha, only constant can be introduced in and out. Okay? Then times what? Times sine of copy, sine 4x dx. So how do we read this now, children? So this is what? This is u. What about this, guys? This is du. What about this? A. Integral of a to the u du. A to the u du. If the sound is integral of a to the u du, what is the answer, children? A to the u. A to the u. Over ln a. But what is my a? Pi over 5. And plus your favorite, C. That's already the answer. All we need to do is to put it in a nice form. So we have pi over 5 raised to sine squared of 2x over 2, then ln of pi over 5, then plus c. Understood, guys? Guys.
Yes po.
Do you have any question with that? So identity is very important, no? We use that in this case. Because if you don't know how to apply identity, you're not able to recognize that sine 4x dx is possible to be the du of sine squared 2x, no? All we have to do is, of course, to supply what is missing, no? Yeah. Let's have number 4. Integral of e to the arc and arc secant of arc secant of square root of w, then dw over square root of sorry. I mean w square root of w minus 1. I'm not really sure if I am having the correct problem. Let me see. Let's check. Let's see. Okay. So what is our u here, guys? Elwin Mark? Sino mga hindi mga pipi dito? Charles Dominic, Carl Andrew. Sumuko kay Sir Elpidio.
Sir, arc secant.
So arc secant of square root of w. I'm not really sure if this problem will really have solution. So let's just fix in case it will not have. So our A is E, so no problem with that anymore because we have a direct integration of integral of e to the u du, and that is e to the u plus c. Okay? What is its differential? What is the differential of this, guys? What is du, guys?
Sir, 1 over square root of 1 minus square root of w squared.
Let's get first the derivative of this. What's the derivative of the square root? That is 1 over 2 square root of what? Of w, no?
Yes.
All over u. Diba u over u? Am I right? What is our u here? In arc secant? Square root of w. Right? Then square root of u. Its u is square root of w. So that is w. I mean square of this na? Minus 1. Actually, the differential, you have already the hint in the given. So you will able to recall, no? Okay na, guys? And dw. Any question with that? How to simplify this, guys? When simplified, this is equal to this w here is multiplied to this w in the denominator and together with the 2. So 2 times square root of w, that is w. Am I correct, children? Children.
Yes, sir.
Then w minus 1. Okay, then dw. Alam nyo guys, para may nag-guide sa inyo, if in case in your family, there is someone in your family who is really good in math, you you let them join, no? Oh, para maturuan kayo pag meron kayong mga hindi maintindihan. Pag-join nyo. Okay, guys? So, this is DU. Oh, almost there, no? Except that there is a missing 2 in the denominator here to be this as DU, no? So, let's have correction factor na lang, ha? So, again, by correction factor, and by correction factor, we are going to correct the differential. Yan. Actually, this is not formal, no? You know, you don't normally see this word in calculus books. But this is just made this term, correction factor, just to understand what we are doing, no? Yan. And let's call such by that name, no? So integral of so this given now becomes what? Oh, what am I going to do? We have e to the u, but what is my u? Arc secant of square root of w. Okay? Chuapoco has left the meeting. Times Alcantara also. Times what? Oh, what is potential du? dw and dw over w square root of w minus 1. Then, what are we going to supply, children? We need to supply here 2, no? Which is in the denominator. Since it is in the denominator, where will I going to balance it? Numerator or denominator?
Numerator po.
Numerator, meaning multiply by 2 over 1 or 2. Okay? Naku, umakyat na naman ang pusa ako. Nanggugulo na naman itong muning-muning. Diyan ka lang, muning. Oh, so this is now read as, although it is color blue, but this is red. Not, although this is blue. This is read as 2 integral of e to the u du. Again, what is this, children? Oh, what is this? What is this? U. What about this, guys? Du. E to the u du. If the sound is e to the u du, what is the answer, children? E to the u. But what is my u? Arc secant of square root of w. Then plus the beautiful c. That's it. Is that correct, children? Guys?
Yes po.
Okay. For additional points, this is for additional points. Yan. Usawag ka magulo. I will be giving you a problem. This one. Okay. Evaluate, no? So the first 5 who will able to get the correct answer, you just post in the comment. I'm going to have in FB where you can comment, no? Scan nyo lang. Ay, by the way, yung sinasubmit nyo, ha? Some of you are submitting, we're submitting not in Excel file. Be sure Excel file, ha? And then some of you had not completed the information. You fill out properly the Excel sheet, ha? Name and so on. Not just the file name, including the information in the Excel file. Okay. Okay, guys? Okay. So this is practice, pero additional points only. Practice, because practice makes minimum mistakes. Okay? So integral of e to the 4 raised to 4 log of secant of x to the base 3. Yan. So then we have hyperbolic sign. Are you familiar with the hyperbolic sign? If not, you Google, no? What hyperbolic sign? Actually, hyperbolic functions are simply exponential functions. Special combinations of exponential functions and given special name. No? Dx all over cotangent x. Over cotangent x. Okay, guys. That's it. Guys, ha? O, yan. Ilang plus ang gusto nyo pag nakasagot? But correct solution, ha? Pati mga notation. Hindi kulang-kulang sa u. Ang du, walang dx. Sa right side. O, plus, plus 10 sa quiz 1. Plus 10 sa quiz 1. Okay, ha? Plus 10. Okay, guys. If you don't have any questions, guys, may questions pa, guys? If you don't have any questions, so bye. I'll just put in a comment, I mean, in the discussion where you can post your solutions, ha? Okay, bye, guys.
Thank you, sir.
Thank you. I will give you plus for attending. Those who will be here,
Thank you,
could you
sir.
please type your name, ha, for your attendance, guys? Because this is not compulsory. Yan, ha. Type niyo yung attendance niyo. Wala na nga habol, ha? Ang kulit ng pusa. Ay, pusa. Ang kulit. Okay.